I'm very, very happy to see so many people here. This is super exciting, so thank you very much. And I just want to point out tomorrow is my birthday, so this is a great birthday present. This talk is about vCenter performance. What I'm going to try to do is give you some insight as to the factors that influence vCenter, and then tell you about the kinds of things that I do when vCenter doesn't necessarily perform as planned. My name is Ravi. I'm a principal engineer in the performance group, and I've been working on vCenter for about 14 years. Most of what I talk about in this presentation is stuff that's already been released, but I will occasionally talk about things that are futuristic and forward-looking, so please keep that in mind. I should also point out that I have given this talk at previous VMworlds, but it's very different and there's a lot of new material. So if you've seen it before, I think you'll still be pleased. So the roadmap for this talk is to do a bit of a deep dive into what's under the hood with vCenter. After that, I'll talk about the sorts of factors that influence performance, and then I'm going to talk about the sorts of things that I look at, again, when things aren't necessarily performing as planned. To start it off, most of you have probably seen the blog article or the announcement that we're deprecating vCenter Windows. And what I wanted to do with this slide is to reassure you about the performance of the appliance relative to Windows. So what I've done here is I've taken vCenter Windows and vCenter Appliance, and I've taken a benchmark that we've written internally, and it's called vCbench. And what it does is it sends a lot of provisioning operations and lifecycle operations to vCenter, like clone, vMotion, power on, etc. And in dark blue you see Windows, and in light blue you see the performance of the appliance, and basically higher is better. Okay, so what you see is in this particular setup I show two sets of bars. Each of them is for a single cluster at the cluster scale limit, so 64 hosts and 8,000 VMs. I've got a so-called light load, which is somewhere around 100 operations per minute, and a heavy load, which is somewhere around 400 to 500 operations per minute. What I wanted to illustrate here is that at those load levels, you can see that the appliance is outperforming Windows. Okay, so from a performance perspective, we're in good shape. I also wanted to point out that if you look at the data center scale, so in this particular case, approximately 1,000 hosts, approximately 20,000 VMs, the difference has actually become a bit more stark. What I show you here is that the out-of-the-box settings for the appliance vastly outperform that of Windows. And this is in the neighborhood of, I want to say, several thousand operations per minute. So quite a bit more intense than a typical customer environment. Now, you can change some Windows OS level parameters and get the performance to be nearly at parity. Most of these are network-related parameters like ephemeral ports or time wait settings. But the point is that out of the box, we've done a lot of work to give you a really good experience with the appliance. As most of you know, there is a migration tool for the appliance. It's started with 6.0 U2M and now 6.5. And if you have questions about the sorts of changes that went in to get us to this sort of performance, I wrote this blog article. And I should point out, if you're furiously trying to take pictures, this is recorded, and I have a new stack of business cards, and I can send you the slides if you want them. So you can just relax and enjoy the show. Okay? Show, whatever. Okay, so next, let's talk about what's inside of vCenter. If you look at a very, very high level, vCenter is basically, you have a bunch of UI clients or API clients, and they're talking to this vCenter server, which is mostly a process called VPXD, and it persists a bunch of data in the database. In fact, this is the architecture when I joined the company. But reality is quite a bit more different, and it's really, really important, and we'll dive into this. It's really important to understand these various pieces because it helps you understand where performance is going in your system. So let's go ahead and give a very, very brief overview. And what I'm going to do is touch upon a few important pieces of this diagram so that you have a better sense of what's really going on inside of vCenter. And the same principles apply whether you're using an embedded database or an external database. So we're going to just assume that it's an embedded database for now. So I'm going to talk through a simple example of just powering on a VM. So when you want to power on a VM through, say, the web client, of course, the first thing you need to do is to log in. And when you're logging in, you go to your web browser, and the first process that the web browser touches is a process called the vSphere client. So inside of your vCenter appliance, for example, the process called vSphere client accepts all requests. And it has a small piece within it called the data service, which helps direct requests accordingly. Okay, so you've got your vSphere client process, and in order to prove that you're you, it has to talk to a collection of SSO services. If you're looking at the appliance, these might be STSD, Secure Token Service. You might see IDMD. You might see VMDRD. All of these things together help enforce SSO. You check your identity usually by looking at Active Directory. In addition, as you know, when you log in using the web client, you need to know not just which vCenter you're talking to, but there might be other vCenters that you're talking to as well. And SSO helps you keep that kind of information. And in order to do that, you need to sort of get permission to see the sorts of things that you're allowed to see. That set of roles and privileges is stored in a separate place called the directory service, and that specifically is called VMDRD. So this service is responsible for keeping roles and privileges, so it basically says, what is this user allowed to see? In addition, it stores licenses and it stores tags, and that will become more important shortly. So anyway, you've basically proven that you're yourself. Now it's time to actually power on the virtual machine. So your request, your power on request gets redirected to the process called VPXD. Now, VPXD is authoritative in terms of determining whether you are allowed to power on that VM. So one of the things that it will do is check again this directory service and check the roles and privileges for you and make sure that you're allowed to power on this particular VM. In addition, it might require some information most of the data is cached in memory, but sometimes it might have to go to the database. So it gets some information. It might also invoke DRS and figure out where it wants to place the VM. In addition, maybe you need to consult some storage profiles to figure out whether it goes on gold storage, bronze storage, or whatever, and to check compliance. And for that, it talks to a service called VMware SPS, or Storage Profile Service. Okay, so you're powering on this VM, you've checked DRS, you've checked storage profiles. Now, what's important to note is that these storage profiles are accessed by talking to a collection of services called VPXD services. In 6.0 and before, this collection of services included an inventory service, which was a cache of inventory information. But starting with 6.5, we've gotten rid of that service. So VPXD services, it consists of a key value store front end to the vCenter database. So your storage profiles are stored as key value pairs in that database. Now, in addition, this VPXD services module is also responsible for tagging. It's got a tagging service inside of it. And those tags are actually stored in the directory service. In addition, the VPXD services module also does authorization for different types of inventory elements that vCenter is not authoritative on. So for example, content library related authorization occurs in that VPXD services module. So having deconstructed this picture, now you get a good sense of the sorts of modules that are within vCenter. Once you've done all of that, your request goes out to the vSphere host, the command is executed, it tells vCenter it's done, there's an exchange of information, it persists information in the database, and then finally tells the user that the operation is done. Okay? Now, there are a lot of other services within a vCenter VM. For example, if you've ever looked at the overview charts in your web client, those are driven by a perf chart service. So what I'm saying is the more things that you exercise within a vCenter VM, the more functionality you use, and potentially the more resources you might use. In addition to all of those services, we have a collection of other auxiliary services. For example, we have a service called vMon, which helps with monitoring the uptime of the service. We have a proxy, we have a content library, we have various health services, a lot of different auxiliary services. And many of those are written in Java or Python. So we have VPXD, which is a C++ service, and then a collection of Python and Java services. So that's what happens on a normal operation. Now, if you have extensions, the picture is largely similar with a few differences. Whenever you install a plugin, for example, NSX or VROps, you install a small bit of code within the vSphere client. That's why we say that when you have plugins or extensions, you may need to increase the heap size of that vSphere client service. In addition, most plugins and extensions actually satisfy their requests through an external server. In this case, I've listed NSX Manager. So if you're making a request to a plugin, the latency between that extension server and your vCenter server is quite important. If it's very long, you might see slower responses. Now, these kinds of plugins and extensions invoke different functionality within the vCenter server. For example, NSX uses ESX Agent Manager in order to install VIBs and monitor those VIBs. So Given that you're using NSX, that means that you're unlocking more functionality, which means you need yet more resources to run vCenter effectively. Okay? Now, to deconstruct the host operation just a little bit more, I drew this graphical picture. So the idea is this. You're a client, and let's suppose you're creating a VM. This request goes to the vCenter server, and the vCenter server has to do a sequence of steps. It goes to the host and, for example, it reserves the name of the VM, does a couple of more steps, eventually provisions the VM, and in most situations, especially with larger VMs with a lot of memory or potentially a lot of disk, much of the time for provisioning a VM is spent on the host in the storage subsystem. In fact, you'll find that when you upgrade your storage, you'll often actually get better performance for these provisioning operations. Once the operation is done, the host tells vCenter it's done, and vCenter issues what's called a get changes or host sync request. And that request goes back again to the host. The host figures out everything that's changed and sends it back to vCenter. I'm emphasizing this because, as you can see, the host component of latency for provisioning operations is quite important. Finally, the remaining changes are pushed into the database at vCenter. After that, the operation is done. There's two critical things to remember about this diagram. Although there are multiple hops between vCenter and the hosts, in most cases, the latency for an operation is bound by the host latency. It's not bound by the latency between vCenter and the host. So many of our customers choose to deploy remote office, branch office, where you have one centralized vCenter and hosts spread throughout the world. And that's fully supported and it should work just fine. There is going to be a little bit of slowness, but it's not as if you use a slower network, you don't get, if you say a 10x slower network, that doesn't mean your operations are 10x slower, because for the most part, your operations spend a lot of their time on the host itself. There is a white paper that we wrote. Although we wrote it many years ago, it's still valid and we're looking to refresh it. Second thing I wanted to point out is you can see that the database plays a critical role before finishing the operation. So it's very critical to minimize the latency between the database and vCenter. Practically speaking, what that means is that if you're running Windows vCenter and you're, for example, running SQL Server, please keep those on the same network segment. Don't put a large number of switches between vCenter and your database. The rule of thumb I typically use is try to keep them within 10 milliseconds of each other. Okay, that's a bit of a deep dive into, did you get that picture? You good? Okay, good. Okay, so that's a single node vCenter. Now let's look at multiple nodes. So just to normalize everybody's terminology, when I say vCenter node, and I'm dealing with a configuration in which you have a separate vCenter node and PSC node, or Platform Services Controller node, the vCenter node is basically everything except licensing, directory service, and SSO, and you'll see why in a moment. The PSC node is all of those components. So rather than viewing them just as text, let's view it graphically. I here show the vCenter server with SSO and licensing taken out. And so this is what a vCenter and then external PSC arrangement actually looks like. And what ends up happening is if you have to access some of those services like SSO and licensing, you end up making calls out to the PSC node. And we have various caches within our vCenter server to make sure that you don't always have to go and make a network hop for that kind of information. Now, this is a single vCenter and PSC configuration, but obviously in most situations, customers have an external PSC because they have multiple vCenters. There are many reasons to have multiple vCenters, and we can talk about that later if you're curious, but let me just show you a sample topology. You have a PSC node. That PSC node has SO, and it's also got the directory service. And because it's got basically a licensing service and because it stores tags in that directory, it means that all of your external vCenters now have access to the same set of licenses and the same set of tags. Okay? And that means that when you connect your web browser, you can see all of the inventory, you can see all of your tags, you can see all of your licenses, etc., from a single place, like I show here. Now, what's wrong with this picture? Okay, that's cool. Single point of failure. If you use this kind of a topology and your PSC goes down, you won't be able to log into your vCenter. So it's important not to use this if you really want high availability. So what I instead recommend is an approach that I'll show you on the next slide. Okay? Now, just to close the loop on this picture, remember that I said that tags are stored in that directory service. Now, a tag basically says something like Windows VM or Linux VM or whatever. The actual association between that tag and its inventory item like it's VM where it's host, is kept in the individual vCenters because an individual vCenter has the actual VM or has the actual host. And so whenever you're accessing tags, you're doing a delicate dance between vCenter and this PSC. Okay? Now, what we really recommend for what I'm going to call a single site configuration, and by single site, in 6.0, we define basically the boundary of a site to be less than 10 milliseconds. In 6.5, our recommendation is for that to be less than 30 milliseconds, and we're constantly looking to try to do more testing to figure out how we can expand that, so please stay tuned for more information on that. We recommend an external load balancer for failover, and if you've started with an embedded PSC and need to go external, there are various scripts for that. So what we recommend is you have your two PSCs and you set them up in a single site configuration. This automatically gives you replication, so anything that changes on PSC1 within a time frame of 30 seconds is supposed to appear on PSC2. Automatic replication, but it doesn't have failover. The way to put in failover is through an external load balancer. Once you've got that, you connect your vCenters to this topology. Okay, and now you have failover of your PSCs. This is a better configuration than in the previous slide. Now, one thing I should point out is that while this gives you availability for your PSCs, it does not give you availability for your vCenters. For that, you might consider using vCenter high availability, which is new in 6.5. Now, let's talk about performance for a moment. And to do that, let me go through an example of search. Okay? Imagine you connect a web browser to one of the vCenters and you're searching for the string DSL. Now, DSL could be the name of a VM, the name of a host, the name of a cluster, the name of a tag, etc. So you have to search both vCenters and PSCs for that information. So the way it works is that your browser connects to your local vSphere client instance. It forwards the request to the load balancer and picks one of the PSCs to satisfy the request. And maybe there's a tag named DSL. In addition, it has to send every request to each of the other vCenters in case any of them have something that has the string DSL in it. Now, this is very important because what does this mean? Number one, if you have a high latency between your vCenters, you're going to get slower responsiveness. And it has to wait for the last vCenter to respond before it gives you a set of results. So if you've ever wondered why this might be slow in a vCenter PSC configuration, this might be why. In addition, the latency between vCenter and the PSC arrangement is also important for exactly the same reason, because some of the information requires you to go to the PSC. Okay? Once you do all of that, you end up getting this nice view right here. So you can actually see any tag or inventory item with this string in it. So this is the preferred configuration for a single site. And remember, for 6.5, we're recommending that that be less than 30 milliseconds per host maximum. And for 6.0, it was around 10 milliseconds. And we're constantly striving to improve that. So that's a single site configuration in what's called a PSC HA config. When you have multiple sites, and by multiple sites, it's basically greater than 10 milliseconds or in 6.0 or greater than 30 milliseconds in 6.5. And our recommendation is having less than 100 milliseconds between these multiple sites. Again, we do realize that this introduces complexity with cross-continental arrangements, and please come and talk to me later, and we're working on sort of qualifying those sorts of setups. So that's a multi-site. Basically, it's somewhere less than 100 milliseconds. What we recommend is that you set up each individual site exactly like I showed you in the previous slide. So this site has replication and failover, and then the second site has replication and failover. If you configure it using the multi-site arrangement, you get automatic replication between those sites. Note, you don't get failover, but you do get replication. So any tag that you change in one of the PSCs will automatically go to any other PSC within 30 seconds. Now let's look a little bit at the performance considerations for this particular setup. So imagine I've got a web client and I connect it to that vCenter server. Well, we all know the drill. Basically, you not only have to go to the PSC, and you only have to go to one because it replicates that information across every PSC. But what's important is that you also have to go to every single vCenter. So again, this means the larger the setup that you have and the larger the latencies that you have, the longer the latency that your search or that your browsing is going to be. In addition, the vSphere client process on the vCenter server you're talking to, right? You're talking to this vCenter server right here, and it has a vSphere client process. That process is responsible for marshaling all of the data from all of the other nodes, before giving it to the web browser. So the larger the inventory you have, the more vCenters you have, the more heap you might need for that vSphere client process in order to get better performance. Two very critical performance-related concerns from this slide right here. And this allows you to see a picture like this. Okay. So what we've done here is we've talked a bit about performance considerations in single node and multi-node. Now let's talk a bit more about that. So I'm going to talk about the 4 most common sorts of questions that I get. The first is, how many operations can I actually do? How do I monitor CPU and memory? How do I look at my database? And is there anything I can do to improve UI performance? So let's go ahead and start with concurrent operations. There are 2 hard and fast rules with vCenter. You can do up to 640 concurrent operations before the rest of those tasks start to queue. So you can log in once and try to issue 640 tasks, or you can have any number of logins, but the point is after 640, vCenter will start queuing them. In addition, vCenter can support up to 2,000 concurrent sessions, so in other words, up to 2,000 concurrent logins or remote consoles, etc. After 2,000, it'll block any login requests. And this used to happen a lot in the past when customers had backup jobs that would log in individually for every host, and eventually someone would try to log in with the client and they couldn't log in. It's because it had run out of sessions. And I'll show you how to detect that in a few slides. So that's the vCenter hard limit. That's a global limit. But what's usually more of an issue is the per host limits. So starting with ESX 6.0 or vSphere 6.0, think of the per host limit in terms of the cost that a host can pay. With a 6.0 host, the host can pay 16. Now, what does 16 mean? Well, the cost for a clone, a relocate, or a vMotion is 2. So think about it. You can do 8 of those at a time before you block. The host for a storage vMotion is 8. It's more expensive, so you don't want to do a lot of those on a host at once. Otherwise, your workload VMs won't be running properly. If you're using linked clones, the cost per linked clone is 1, so it's cheaper than a normal clone. However, you have to take a snapshot first. If you don't take a snapshot first, vCenter will take a snapshot before it does the linked clone. This means if you issue a large number of linked clones, each of them is going to wait for a snapshot before it continues. And so if you've ever wondered, why am I not getting better concurrency, maybe that's why. In addition, if you're cloning a powered-on VM, then vCenter has to, that's similar to linked clone, vCenter again has to take a snapshot before it lets that clone continue. So if you send a lot of clones of powered on VMs, that's one thing that might be limiting your scalability or your concurrency. Now, I'm going to try to explain this using a picture because I think it's a little bit easier. Did you get that picture? Someone was taking a picture over here. Okay, there you go. You got it? Okay, sounds good. Okay, good stuff. So imagine I'm cloning a VM from host A to host B. Host A gets charged 2. It's a clone and it's the source. Host B also gets charged 2 because it's involved in that clone. Okay, so the way you can think about this visually is that each host is being charged 2, and that's what I show in red, and then each host has a number of free slots. So those free slots can be taken up by any of those other operations I talked about on the previous slide. Now let's contrast that to if you were to clone a VM from a host to itself. You can sort of imagine what happens. The host gets charged as the source, so it gets charged 2 units. It also gets charged as the destination, so it again gets charged 2 units. And the picture looks something like this, where A actually has fewer free slots than it had in the previous case. Now the reason I bring this up is that what used to happen a lot in the past, and I think we've hopefully gotten people away from this, they would have, for example, a VDI setup, and they'd have one template VM, and they would issue a massive number of clone operations to this one template VM. Well, think about it. If there's only one template, it's going to be sitting on a single host. After 8 of those clone to VM, the rest of those clone operations have to wait. And so a better approach is to actually have multiple golden clones, multiple golden templates spread throughout your infrastructure. That'll get you much better concurrency. So we saw the vCenter limits and we saw a per host limit. But there are other limits that are very, very important. For example, there are per data store limits. A given data store can be involved in up to 128 the cost that a data store can absorb is 128. And to put that into context, a vMotion costs 1. So for a given data store, 128 vMotions can be occurring at once. A storage vMotion costs 16. So for a given data store, about 12 of those can occur at once before the rest have to block. Now this becomes even more important when you have vSAN, because vSAN, of course, exports a single data store. So be careful of that as you build out your vSAN deployments. And that's why having multiple vSAN data stores is a good idea. The final limit that I'll talk about is the per NIC limit. I'm only going to talk about 1 gig and 10 gig for the moment. 1 gig has a total cost of 4 that it can absorb. 10 gig has a total cost of 8, so it has double the capacity. So and the cost of a vMotion is 1. So you can see that for a 1 gig NIC, you can do up to 4 concurrent vMotions. For a 10 gig NIC, you can do up to 8. Now, our best practice is to have you deploy a separate vMotion NIC and deploy a separate vSphere provisioning NIC so that you can get maximum concurrency across those NICs. It doesn't have to be a NIC, it can also be a port group, by the way. Now, you can change these limits. Unfortunately, this is not officially supported. The rationale for that is that we try very hard, when you give us more resources, to consume them more efficiently so that the end-to-end time for an individual operation is faster. So you could, for example, issue 100 vMotions at once, but all of them would be slow. If instead you issue 8 at a time and they're all able to consume the entire bandwidth of the network, then they will get done faster, and ultimately 100 such vMotions will get done faster. So that's why we don't arbitrarily make these limits. Having said that, I do occasionally talk to customers that say, hey, I have a really beefy disk or a really beefy network. I think I can do more. And we're working with the provisioning and lifecycle team to see what we can do to make this more adaptive. If you feel like you're limited by these things, please come talk to me afterward. Okay, so that was a bit of a deep dive on concurrency. Next, let's talk about CPU and memory monitoring. Here's my rule of thumb. If your vCenter CPU, this means the entire vCenter server, is 70%, you should not let it exceed 70% on average. Okay? If there are occasional peaks above 70%, that's totally fine. But if it is constantly above 70%, what I worry about is you haven't given yourself enough headroom in case a sudden spike occurs. Okay? Now, if the CPU is above 70%, it's time to do a little bit of digging, and I'm going to go over that in more detail in the subsequent slides. But basically, the workflow is to see which process is taking the most CPU. If that process is VPXD, it's a C++ process, maybe you need to add more CPUs to your vCenter server, or maybe you have to split out your environment. If it is one of the Java services, you might have to increase the memory, the heap memory for that Java service, because maybe it's spending a lot of its time garbage collecting because it doesn't have enough memory. What I often see is when CPU is very high, it's often because of plugins and extensions. And so I'm going to show you how to get some information about what those plugins and extensions are doing. And often what that amounts to is you talking to your vendor and trying to understand what sorts of things they're doing and sort of making sure to map that to your environment properly. In terms of memory, I have a similar rule of thumb. vCenter is very sensitive to memory, so please make sure you don't exceed 70% on average, and if you do, you probably want to add more memory. If, above all things, you definitely want to avoid swapping a vCenter. If you are running vCenter in a VM, please make sure to set a reservation equal to the size of the VM for that vCenter to make sure that you're not going to have any sort of host level swapping. Okay? Now, in order to monitor these things, in 6.5, you might have seen this in an earlier session, we now have an appliance management interface. It's port 5480. It can show both CPU and memory. I have only shown you the CPU chart here just to make the slide cleaner. But as you can see, for the most part, the CPU is pretty low and there's an occasional spike at the end. You're looking for something like this if things are starting to go wrong. You're looking to see if that CPU is spiking up to 100% or something above 70%. Then you might want to take some action. And similarly for memory. Now, if it is that high, remember what I said a few moments ago. I said, hey, you should probably look and see what's taking all that CPU. So let's discuss how to do that. First for Windows, and then the appliance. In Windows, obviously, many of you use Task Manager. And due to, I won't say a quirk, but due to limitations in the Windows platform, our services, basically, most of them have the name Java. So you can't really tell just by inspection what that service is. Some of our services have usernames that map to their functionality. In this case, the username VDCS, it used to stand for something else, but now it's content library. So you can look at something like that and know, okay, that's content library that's taking that much CPU or memory. But for something like this, all you have is a PID. And so what I actually do is I install the Process Explorer tool from the sysinternal suite of tools. Thank you, Valentine. My colleague gave me a little bit of grief for saying that wrong. So anyway, I always install Process Explorer, and with Process Explorer, what I can do is locate the same PID, and then I deeply apologize that this is so ugly. Trust me, we're trying to make this better, okay? And when I gave this talk in Vegas, somebody actually tweeted that picture of me saying that, so please don't do that. Anyway, the point is, when you mouse over it, you can see the command line, and you can see very early on in that command line the name of the log file for this process. Like I said, we are working on making this better. But in this case, what you see is that this happens to be the inventory service. Remember what I said, in 6.5, we've gotten rid of the inventory service, so this will not appear, but this is a 6.0 configuration, and that's why it's there. So this is how I actually look and find out which service is taking how much memory or how much CPU when I'm using Windows vCenter, okay? If you're using Linux, if you're using, the appliance, if you enable troubleshooting mode and enable SSH, you can use a tool called VMTop. It's available on the command line, just type VMTop. And it shows you an English language description of each of our services. So it's a bit more usable in some sense than the task manager. It'll show you CPU usage, and in terms of CPU usage, when you see something at 100%, it means that it's taking 1 core. If you see something at 200%, it's taking 2 cores, etc. Okay? In terms of memory, it'll show you what's currently allocated, and so you can use that as you might use the similar counter from the task manager. Okay, so these are how you can look and see what's taking the most CPU or what's taking the most memory if you happen to be using the appliance. Okay? Now, where have we come from so far? I've said it's important to monitor CPU and memory. I've given you some 70% rules of thumb, and I've told you what sorts of things to look for to see what's consuming CPU and memory. I also said that in most cases when I'm talking to a customer and they have extremely high CPU usage, it's typically because of a plugin or an extension making some requests to vCenter. So let's dig a little deeper into that. In the web client, in 6.0 and in 6.5, it's in a slightly different place, but either way, it's under the Sessions tab. If you go to this view and enable 2 optional columns, they're not enabled by default, you can enable a user agent column and an API invocations column. This is a great way to get a first glance at what is doing what against your vCenter server. Okay? Now I show a couple of things in this chart. The first is that, as you can see, at the far right is the username. Please give your services sensible names. Sensible login names, because if you don't, you'll get a line like this that says the administrator user is making a lot of requests, and you'll have no idea who that is. Okay, so a best practice is please use sensible names. All of you already do that, so probably preaching to the choir, but just saying it one more time. So in this case, I happen to know that that's NSX, but let's ignore that for the moment and focus on a different one. I gave this one a sensible name, VRA. VRA is making a couple hundred API invocations since vCenter is up. Let's dig deeper and find out what's going on. Okay? So, to do that, this is again something that we're working on improving the workflow for. So a lot of this is what I do when I'm faced with an escalation and what GSS might be doing, and in the future we're going to make this simpler. I'm really sincere about that. But for now, let's look at some of our log files to figure out what's going on. The important one to look at is a log file called the profiler log. This profiler log is in these locations in the appliance and in Windows. Okay? And it gives you a lot of useful information, and the format of that information is basically a key value pair. In this case, I show you the number of sessions. Now remember what I said a few slides ago. I said that if you hit 2,000 sessions, no one can log into vCenter. So what you're really looking for is for that number of sessions to be 2,000, and you're looking for an entry in the VPXD log, not the profiler log, but the VPXD log, an entry that says what I've shown here, that you've reached the limit of 2,000 sessions. The reason you have to look in both places is that vCenter can do a limited amount of garbage collection of sessions, but it can't necessarily garbage collect every single one. That's why you look at both to see if you're running up against this session limit. So that's step number 1, are you running out of sessions? Step 2, what are those sessions actually doing? In that very same profiler log, in addition to seeing session information, you also see lines like this. It's per session information, and I've highlighted in blue the most relevant pieces. The ID of this session, the username of that session, and the IP address of the session and where it's making that call from. So let's keep this set of information in mind. Again, we're getting this from the profiler log. We've got a session ID, a username, and an IP address. Now, let's take a look at the VPXD log. Okay, many of you are probably familiar with the VPXD log, and I give the location in that place right there. Take the session ID from the previous slide, look in your VPXD log for calls that have that session ID, and that'll tell you exactly what that session is doing. In this case, that session is making a query event call. Now, this is actually very interesting. It turns out this was our VRA user, and what's happening is that part of how VRA checks its connection to vCenter is by making a query event call, which ultimately is a database call. When I was looking at this happened to be a customer escalation where I realized that their database was getting pounded by traffic. And when I eventually found this, that's when I realized, oh, okay, VRA is making these calls, so we're fixing that in some future release, no promises. But the point is, this is a good way for you to know what it's doing, and then maybe if you're on the phone with GSS, together you can figure out, oh, that's why this particular resource is getting exhausted. So hopefully you'll find this piece useful. I use this a lot. Okay, so we've talked about CPU and memory. Now let's deep dive into the database. You all know that the database has a lot of different jobs. You can go ahead and take a picture. I'm not animating on this one. Okay, he's in. So the database does stats roll-up, so it takes stuff from past day to past week to past month, and past month to past year, and it does that automatically on a schedule. It's also responsible for, if you've ever looked in your UI client, you've seen top N VMs by CPU or top N VMs by memory. That's also computed by the database. In addition, of course, the database, whenever a host finishes a task and sends the list of changes back to vCenter, that's called a host sync, and vCenter has to put that information in the database. And of course, if you make historical stats queries, so past day, past week, etc., those go to the database. And finally, the database is used to persist events and tasks. So, if you attach nothing to the database, if you just have vCenter in your database, it's important to note that the database traffic is very write-heavy. And the most write-heavy partitions are the database log, so the transaction log that lets you have your ACID properties of a database, the database core partition itself, so this is what keeps inventory information like hosts, VMs, etc., and the so-called seat partition, stats, events, triggered alarms, and tasks. All of those are write-intensive, and so if you have the choice, please put those on something that's low latency, high bandwidth, for example, an SSD. And if you're in Windows, you might choose to use different table spaces for them so you can put them on different storage. If you are experiencing slow API calls, the workflow I typically run through, and again, these are primarily for slow stats queries or slow event and task queries. I typically obviously check the database resources. I'll show you how to do that in a minute for the appliance. Of course, check CPU, memory, etc. Definitely check the database space. In a lot of situations, a customer's database is running low on space, and this can unfortunately, if it gets to a certain point, cause vCenter to crash. So even if it's not directly responsible for your slow API calls, if you are getting stressed, it is important to make sure that you do have enough space. We have vCenter alarms to help you avoid running out of space. And I'm going to show you in the next slide how you can use the same appliance management interface that shows your CPU and memory to show you the database utilization as well. And in some cases, if you're running up against space constraints, you might have to reduce the retention interval of your tasks and your events. The default is 30 days. Sometimes you might have to reduce that if you find that you're running out of space in your database. And sometimes also, you might have to lower the level of your stats level. And I'll talk about the implications of that in a few slides. Finally, sort of a last-ditch effort is sometimes if you're really, really running low on space, in conjunction with GSS, sometimes we ask you to truncate those tables so you can start fresh and have nothing old in your database. So I mentioned that it's important to check space, so let's show you how to do that. We all know how to do that on Windows, I presume, so let's look at the appliance. In the appliance, in the same URL that I gave earlier, and this is new in 6.5, you can see the composition of your database. And specifically, you can see that the transaction log in this case is taking this much space, and you can also see the breakdown of the partitions that typically take the most space in the database. Typically speaking, the stats, events, alarms, and tasks takes the most space, and the transaction log takes the most space. Those are the largest by volume, and that's what this diagram shows right here. You can see that the inventory is quite a bit less consumption. So that's disk space, okay? Now, If you want to use the command line in the appliance, you simply do a df command, and you can see all of the different partitions that are taking up space. And here I highlighted the very same partitions that I showed you from the previous slide. Log, transaction log, the seat data. The DB is the core data, DB log is the transaction log, seat is stats, events, triggered alarms, and tasks, and log is for, say, VPXD log or the profiler log. So that's a total dump of what the disk space looks like. Now, in 6.5, we now have a space alarm, and I highly, highly recommend you use this. The default setting is that at 80% you get a warning. At 95% it actually shuts down VPXD. So I would strongly encourage you to set an alarm action and send yourself a warning, and you can vary this 80% and this 95% through some advanced options. Now, unfortunately, there is a bug during certain upgrade paths where this alarm doesn't show up, and we have ways to get around that, and if you talk to me offline, I can get you some information about that. Okay? In fact, I should point out that when I gave this talk last time, a customer came up and showed me in real time that he didn't have this, and that's why I thought I should point that out now. So, anyway. Okay, so that's one component of checking your database health. But of course, your database is a service, just like all of the other services we talked about. So you can also check the service health from your web client. And it's important to do this because, for example, look at the kind of information you can see here. In this case, in my environment, roll-ups from the past week to the past month are not occurring. If they're not occurring, that also takes up space in your database. So you definitely want to make sure that your database is healthy. And here are some ways to know how that's true. Now, I've said many times that events are one of the things that take up the most space in the database. Let's now understand how to dig deeper into that. If you just go to the client and go to the Events tab, you can get a summary of what sorts of events are happening and therefore what sorts of events are being persisted in your database. This is a bit of a limited view because we only keep a cache of, I want to say 100, but there's some limit to how many we can show at once. You can, of course, use Power CLI, and you can tune that to get different types of events, etc. Very often, when I'm on a call with a customer and I want to see this information, I actually use direct SQL calls. Now, did you want to get a picture of that? Okay, you're good. I don't mean to keep stopping, but I don't want to, I want you to have a good experience here. Okay, so the schema for our database is not publicly supported. So a lot of times I do this kind of as an internal thing, so you'd more likely do this when you're on the phone with a GSS or with me. But if you're genuinely curious and you don't mind the fact that this might change in future releases, what I do is I log in with the SQL Management Studio and I do two very simple SQL statements. One that tells me how many events there are in the database, and the second one which tells me the breakdown of events in the database. And in this particular picture, what's interesting is that it's exactly what I see in virtually every customer environment that I look at. The number one and number two events are almost always user login events. This is not just a user logging in through the client. This is also an extension logging into vCenter. This is also, if you have any tools that communicate through the API directly to an ESX host, that also counts as a login. So a lot of people have tools, they have stats tools or whatever, where they go directly to the host and they have 500 hosts and they do this every 20 seconds. If you do that every 20 seconds, you're going to see 500 events in the database. That causes the space to accumulate, and that's not necessarily a good thing. That's why we ask you to use our APIs and go through vCenter if that's an option for you. That's Windows. If you want to do the exact same thing in the appliance, you enable troubleshooting mode, enable SSH. This number 2 is the command line that you'll use that will get you a SQL prompt. So it'll give you the exact same interface that I'm showing you up here. And then you type the exact same query and you'll get exactly the same information. So you can get the same information whether you're using Postgres or Windows. In general, if your database has fewer than 100 million, or if your events table has fewer than 100 million rows, I typically don't worry. When it's above 100 million, I start to make sure that your disks aren't incurring a lot of latency. And this is what I typically see in a lot of customer setups. So keep that as sort of a brand. And of course, this depends heavily on how beefy your database system is and stuff like that. But it's kind of a nice rule of thumb. Now, I talked earlier that the other thing that takes up space in the database is stats. So let's talk about that for the moment. I show here 3 configurations. 2 VMs, where the only difference is the number of disks, and a host. Obviously has a different config. The next thing I'm going to do is I'm going to change the stats level and show you how the volume of stats changes. For VMs 1 and 2, you can see that the main difference is due to the fact that there are more disks. When you jump from stats level 1 to stats level 2, that's where you typically see the largest jump in the number of stats that are going into your database. And that's because at level 1, you might have aggregate stats, like for overall CPUs in the system, this is the aggregated CPU, or this is the aggregated disk latencies, or whatever. But when you go to stats level 2, you start to get some of those stats, particularly network and data store, on a per network, per NIC, or per data store instance. By doing that, you can understand the more data stores you have, the more the stats are going to blow up when you get to stats level 2. By looking at this, you can see why we politely request that, if possible, keep the default setting of stats level 1. And if a tool is asking you to go beyond that, you might want to push back and ask, well, what are you doing that needs that? But the other thing you can do is you can come and talk to someone like me, or maybe we can talk through the PMs and find out what stats you're looking at, because we're constantly trying to improve the sorts of stats that you can get at different levels. So if the stats at level 1 aren't enough, and I do realize there are many very, very useful stats at 2, 3, and 4, please come talk to us. And also, I've got a bunch of tricks you can use using the API to get that data, even if you don't want to increase the stats level. So you can talk to me about that offline. Okay, the final deep dive into the Windows database. When I'm really, really stuck, and this is exactly what I did when I was looking at that VRA situation and I saw that query event call and it happened to be correlated with high database usage. I use what's called the SQL profiler. If you're using Windows, your DBA will definitely know what this is. You don't want to enable this for a long period of time, but if you enable it and look at the traffic that's going into your database, you can see the CPU usage, and this is in terms of percent. So 141 means 141%, or 1.4 cores. You also see the number of reads and the number of writes. If you're seeing high CPU and a high number of reads or writes for a given transaction, now that might be completely normal, but if you're wondering why your usage is so high, this is a good way to find out, because you can then mouse over that particular transaction and figure out what is this transaction doing. Typically, again, this is going to happen perhaps on an escalation call, or maybe when you're on the phone with someone like me and I'm looking at this. But if you're genuinely curious and you're not afraid to look at the SQL profiler, you don't want to enable this for very long because it does cost overhead, but it's a very good way to get some insight as to what's causing reads and writes or CPU usage in your SQL database. Okay? For the appliance, you can do a very similar thing. I show you the command line at the top. It's a command called pgtop, okay, pg_top. If you see a line like this that ends with declare cursor, that's typically a stats query. Okay, if you want more information, you hit capital Q, the PID, and you can see exactly what that query is. If you want to see the number of reads, writes, etc., you hit capital R. If you see a line like this, auto vacuum, that should typically run very frequently, but for a very short amount of time. For the very short amount of time that it runs, it'll take a lot of CPU, but it should not run for a long time. If it does, that is often a sign that there is some sort of corruption, and that's when you go ahead and call GSS and try to do some sort of debugging. But anyway, it's a completely normal thing to see this takes large amounts of CPU for very small amounts of time. And you can again do Q and find out more information about that as well. So the point is, the same information you get in Windows, you can get in the appliance. And if you want to look at log statements, you're using log insight. If you see a statement like this, which has execution elapsed time and execution took too long, if it's for a stats table, it tells you the name of the table in the log message. That's typically totally expected to take 3 or 4 seconds. But if it's any other table, you might want to make sure that your database is properly provisioned. If a lot of transactions are taking 3 to 4 seconds, that's unless it's stats or unless it's events, that's usually a sign that you want to take a deeper look at your database. And if it's 10 or more seconds, you definitely want to take a look. Again, the exception will be stats and events. So stats and events usually are in the neighborhood of 3 to 4 seconds to 10 seconds, and that's completely fine. And if you have slow historical queries, like I said, make sure you have sufficient disk space. Maybe you have to purge your database tables or change the retention interval. Maybe if you're running on SQL, you have to recompute the stats for your database engine, etc. But above all things, make sure you've got low latency and high bandwidth for those partitions: seat, the database core tables, and the transaction log. Okay, we're almost done. The final thing I wanted to talk about was UI performance. In general, you definitely want to make sure you have the proper heap, because the more vCenters you have, the larger the heap needs to be. The more extensions and plugins you have, the larger the heap needs to be. The larger the inventory you have, because you're marshaling up more data when you do a request. the more heap size you might need. Just to avoid having to constantly click and say, I accept the certificate, load the certificates into the browser, make sure that the machine that's running your browser has at least 2 vCPUs. And make sure it's got at least 4 gig, although it should have much more than that. This is typically more important if you're running it in a VM, because those are typically smaller than someone's laptop or desktop. Often what I'll do is if I have a slow connection between my browser and vCenter, I'll try to use a jump box to get into the same, to make the, remote desktop into something and make it so that it's a faster LAN connection between my vCenter and my browser, rather than going over a VPN and over a slow network. So definitely check the connection between the browser and your vCenter. And like I said earlier on in the talk, make sure that when you install extension servers that they're close to your vCenter server so requests that get sent there aren't slowed down. As far as heap, and we're almost at the end of the talk, here's how you might do this in the appliance, and a similar thing would hold in Windows. You look at VMTop and you see that CPU is high. If it is consistently high, not if it's occasionally high, because that's to be expected. If it is consistently high, then you look at memory, and memory is taking up some amount of time. What I often do is I will cross-check this memory with the output of Cloud VM RAM size. This tells you the allocation that you're giving to each service within the Cloud VM or within Windows. And it's an approximation because there's some shared memory that isn't captured by Cloud VM RAM size. But generally speaking, if the memory that you're seeing in something like VMTop is much, much more than the allocation that you see in Cloud VM RAM size, that's a sign that you probably need to increase the allocation of that service. Okay, so high CPU usage, memory usage in VMTop or Task Manager that's very close to what Cloud VM RAM size gives, usually a sign you should increase the memory allocation. And the way you do that is by the Cloud VM RAM size command, as I show you here. It's on the command line in the appliance, and on Windows, that's the path. Okay? Okay, as soon as that person's done, I'm going to the last slide. Great, we're done. So, just to summarize, if you're concerned about moving to the appliance because of performance, I sincerely hope that we've shown you enough data that you should not be concerned about that. Now you have a better idea of what takes resources within the appliance and what you might do if you see that. Definitely if the load's higher, or if you have a large inventory, or if you have high latencies, all of these things, or if you have plugins, all of these things matter. The biggest thing I hope you've taken away from this is that the appliance does indeed have a rich set of debugging tools that you can use. And so, as we try to improve the manageability, we're giving you an experience that, well, hopefully out of the box is great, and you'll never have to do this, but on the off chance you do, you'll have a place to start. With that, I'm happy to take questions. And I should point out there are a couple of other performance-related sessions in Barcelona that I encourage you to go and see. You not only there are a couple of challenge labs. The performance group has a survey that we like to put out to make sure that we can constantly improve our content. So this is separate from your standard VMware survey. So you can either go to the URL or access this QR code. Okay. Finally, I've been asked to remind all of you, if you don't mind, to please fill out your survey so that we can constantly improve our content. This is the VMworld survey. So with that, I'm happy to take questions. And again, I will be here. I will be outside if we get kicked out of the room. And if you don't get a chance to talk to me, come and I'll give you a business card. We'll talk later. Thank you very much.